So we're expanding on parallelograms and we're doing special parallelograms. So special parallelograms. What are the properties? Well, we know that because they're a parallelogram, that their opposite sides are parallel. We know opposite sides are congruent. We know opposite angles are congruent. We know consecutive angles are supplementary. And we know the diagonals bisect each other. Those things are a fact. Now, depending on if it's a rectangle, a square, or a rhombus, you will add, okay? So the rectangle is going to have 2 extra properties. The rhombus will have 3 extra properties. And then the square has 5 extra properties, okay? So go ahead and draw your diagonals here in the rectangle, because the properties are, it has congruent diagonals. So this is why I am trying to get you to say the diagonals bisect each other, not that the diagonals are congruent, because they're not congruent unless it's a rectangle, okay? And a rectangle has 4 right angles. All right, next I want you to look at the rhombus. I'm going to go to the end to the rhombus. Okay, in a rhombus, opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. And the diagonals bisect each other. Now, what makes it a rhombus is that it has 4 congruent sides. It has perpendicular diagonals. And the diagonals bisect the angles. So now not only do the diagonals bisect each other, but now they bisect the angles too. So go ahead and draw your diagonals in here so that we can mark it correctly. So now the diagonals are perpendicular. And now this piece is equal to this piece. This piece is equal to this piece. This angle equals this angle, which equals this angle, which equals that angle. And this piece equals this piece. Now a square. Now I said a square has 5 extra properties. It's the rectangle and the rhombus combined. So it's not 5 additional properties. So you learned 5 properties yesterday, and you're learning 5 properties today, altogether 10. Okay, so a square, it has 4 congruent sides, it has 4 right angles. So it takes the right angles from the rectangle and the sides from the rhombus. It takes the congruent diagonals from the rectangle. It takes the perpendicular diagonals from the rhombus, and it bisects. Okay, the square is the easiest one to do, and y'all are going to see why it's the easiest whenever we start the problems. All right, so let's take, it says for any rhombus MNOP, decide whether the statement MO is congruent to NP is always sometimes true. Draw a diagram and explain your reasoning. So draw a rhombus, and we know this is going to be a rhombus because all 4 sides are equal. This is equal to this, and this piece is equal to this piece. The diagonals are perpendicular. Now it says decide whether MO, so MO is congruent to NP. Is it always or sometimes true? Well, it's sometimes true because sometimes it could be a square. Okay, a rhombus is not a square, but a square can be a rhombus. Okay, so if the rhombus is a square, so if I take the 4 congruent sides and make it a square instead of a rhombus, then the diagonals are going to be congruent. Number 2, for any rectangle PQRS, so draw PQRS, make sure your letters, the naming goes consecutive. Decide whether the statement angle PQS, so you're going to need a diagonal so that you can get that angle in there. And RSQ. Is this always sometimes true? Well, if this side is parallel to this side, this is acting as a transversal. So these will always be true because they are alternate interior angles. The diagonals of rhombus ABCD intersect at E. Well, since this is a rhombus, what do we know happened to the diagonals? Well, we know they bisect each other, and we know they are perpendicular. So when you have a rhombus, make sure you put the right angle mark at the center so that you realize, oh, I've got right triangles. Angle BCA is 44, which they have marked, and AB is 9. Well, if AB is 9, then I know CD is 9 because opposite angles are congruent, or sorry, opposite sides are congruent. But I also know that these two sides are also 9 because the property of a rhombus is all 4 sides are equal. So I don't have to worry about finding it, I already know it. I also know that if this angle right here is 44, I know this one is 44, this one is 44, and this one is 44. Because in a rhombus, the diagonal bisects the angle also. Since this is 90, what do we know about these two angles? We know that they have to add up to 90. So that makes it 46, 46, 46, 46. I also know that this is 7 because this is 7. I know these two sides, so I could do Pythagorean Theorem and get the third side. Since this is the hypotenuse, then that would be 9 squared minus 7 squared. Take the square root. So 81 minus 49. So 32. So the square root of 32 is 5.65. So I'm just going to put 5.7. So that makes these two pieces 5.7. So I was able to find every single angle in every single segment in that rhombus because everything's equal. So it makes it a little easier. So BC, so I look over here, BC is 9, AC is the whole diagonal, it's 14. And the measure of ADC, so ADC, so this whole angle here is 46 plus 46, so that makes it 92 degrees. All right, the next one we have is a rectangle. A rectangle, the properties are, so I'm going to mark my picture. I know this side equals this side. I know this side equals this side. I know all 4 pieces of my diagonal are equal because that's the rule in a rectangle. If this is 31, I know this angle is 31. So is this one, and so is this one, because you get isosceles triangles. Okay. In a rectangle, this is 90 degrees. Well, if that's 90 degrees, then I can subtract 31, and I can find out that this other half, or this other part, not half, this other part of the angle is 59 degrees. I also know that I have 4 isosceles triangles. Well, if these two angles are 31 apiece, so that would be 31 plus 31 is 62. and I subtract from 180. So 180 minus 62 is 118. Then I know this angle is 118 and this angle is 118. So these are 62. So again, just by knowing the properties, there's lots of stuff that's equal to each other. So you don't have to do a bunch of math. You just do it once and then apply it to every other piece. All right, the measure of FHG. So F to H to G is this angle right here. So that is 59 degrees. HF is this diagonal through here. Well, EG is this diagonal, and I know the diagonals are equal. So if EG is 17, then HF is also 17. And the measure of EFH, so EF to H is this angle here, which is also 59 degrees. Mercy. All right, now we have a square. Since I have a square, all the things that I know these four sides are equal to each other. I know these four pieces are equal to each other. I know that these four angles are right angles, and I know these four angles are right angles. I also know that these are all 45. So when it's a square, these will be 45. The square is the easiest one because the angles are either 45 or 90. There's no 56s or 31s or anything like that. It's either the right angle or it's split in half. End of story. Says MK is 1/2. Well, if this is 1/2, then this is 1/2. So that makes the whole diagonal MP, so the whole diagonal MP is 1. Well, then that makes LN, the other diagonal, is also 1. So if you look closely, I'm going to outline it in green. If you look at the little triangles that are drawn here, so if you look at this triangle here, that is a right triangle, okay, because this is 90 degrees. This is 1/2. So therefore, this is 1/2. Do you know two sides of a right triangle? Do you know two sides? Yes. So I can do Pythagorean Theorem so that I can find the hypotenuse. So I would do 1/2 squared plus 1/2 squared, and then I would take the square root. So 1/4 plus 1/4 is, square root. So 1 squared is 1, 2 squared is 4. Yes. So now I've got 2/4. So now I'm going to take the square root of 2/4. Well, what is the square root of 2/4? So it's 0.71. So that means all my sides are 0.71. So now answer the questions. PK. Well, PK is this piece here. It is 1/2. The measure of PKN, so PKN is 90 degrees because the diagonals are perpendicular. MNK, so MNK, that's this angle here, and that's 45 degrees because the diagonal splits it in half. All right, so you are building a frame for a window. The window will be installed in the opening shown in this diagram. The opening must be a rectangle. So if it has to be a rectangle, that means it has to have 4 right angles and congruent diagonals. Given these measurements, can you assume that it is? Well, I see that this side is equal to this side, and I see that this side is equal to this side. So I do have opposite sides are congruent, but that only tells me it's a parallelogram. It doesn't tell me it's a rectangle. To be a rectangle, it has to have 4 right angles and it has to have congruent diagonals. Otherwise, it is just a plain old ordinary parallelogram. So you measure the diagonals. So now we're going to go in here and we're going to measure the diagonals with the tape measure. And we find out that the diagonals, when we measure them, are 54.8 and 55.3. They're very close. But what can we conclude? Well, we conclude that to be a rectangle, the diagonals have to be identical. They're not identical. They're close. Since the measurements are not equal, it's just a parallelogram. It is not a rectangle. All right. In this one, we have rectangle, QRST. So as soon as I see that it's a rectangle, I want to put the marks. I want to mark my picture so that I know. So in a rectangle, all 4 of these are equal. These 2 are equal. These 2 are equal. This equals this. This equals this. And then these 4 are equal to each other. So I just try to put the marks, because really if you put the marks, you only have to write a number 1 time. And then everything that has that same mark is that same number. And you don't have to rewrite it. It's easier to just put little tick marks. All right, it says that QS, so QS is my diagonal. So QS is a diagonal. Since QS is a diagonal, I know it's equal to the other diagonal, RT. So since QS is equal to RT, then 5x minus 31 is equal to 2x plus 11. So I subtract 2x from both sides. So when I subtract 2x from both sides, that goes away. And then I'm going to add 31 to both sides. So I get 3x equals 42. So we're subtracting 2x and we're adding 31. And then we're going to divide by 3, and we find out that x is 14. Well, if x is 14, I'm going to plug it in. So 5 times 14 minus 31. So 5 times 14 minus 31 is 39. 2 times 14 plus 11 is 39. So I proved mathematically that my diagonals are indeed equal to each other. All right. What is the specific name? The most specific name. All right. So here, this piece equals this piece. This piece equals this piece. So what do we know that this is? All we know is that the diagonals bisect each other. So what would be the most specific name? It is just a plain old parallelogram. Okay. I will tell y'all 15 and 17 we have not talked about yet. We'll talk about them next time, so I'm going to give y'all a heads up. If you'll notice, this side equals this side, and this side equals this side. So opposite sides are not equal. So it's not a parallelogram. But this is called a kite. Okay. This is definition a geometry kite. So this equals this equals this. So again, opposite sides are not equal, so it is not a parallelogram. It is a kite. Okay, so these 2 are not parallelograms. Now this one has 4 right angles. Okay, that's all I know is it has 4 right angles. So the most specific name is a rectangle, because that is one of the properties of being a rectangle. All right, and that is it.